This is Algebra 2, Lesson 7-5, Exponential and Logarithmic Equations. An exponential equation is an equation in the form of b to the cx equals a, where the exponent includes a variable. A logarithmic equation is an equation that includes one or more logarithms involving a variable. Now, you can use logarithms to solve exponential equations, and you can use exponents to solve logarithmic equations. In other words, you can transfer back and forth between either form. So, let's take a look at solving an exponential equation with a common base. Okay. So, what is the solution of 27 to the 3x equals 81? Okay, in this particular problem, 27 to the 3x equals 81. I know that 3 cubed equals 27, and I also know that 3 to the 4th equals 81. These are things, hopefully, at this point in time in your mathematical career, you are beginning to pick up on. You should know that 81 is 9 times 9, and 9 is 3 times 3, so 3 to the 4th equals 81, and 3 to the 3rd equals 27. So, I could rewrite this equation, since I know these two things, I could rewrite this so that 3 to the 3rd to the 3x power equals 3 to the 4th. Okay. Now, if two numbers with the same base are equal, then their exponents are equal. We know that. So if I wanted to simplify this, this would become 3 to the 9x equals 3 to the 4th. They have the same base. Therefore, 9x has to equal 4. So then I can solve this by 9. X equals 4/9. So the solution of 27 to the 3x equals 81 is x equals 4/9. So in other words, 27 to the 3 times 4/9 power gives me 81. I can check that. I can check that really easily by just putting that in there. If I do 27 to the 3 times 4/7, I should get 81. Okay, so that's 27 to the 12/7 power. That should give me 81. If I stick that in my calculator, if I stuck in 27 to the 12/7 power, 27 to the 12 divided by 7th power, I should get, okay, and I'm going to get a decimal. Okay. Okay, so, 4/9, not 4/7. That would make no sense. Like, I didn't get the right answer. So it should be 12/9 power. What is 12/9? It's 4/3. Okay, so if I take 27 to the, I can make it 12/9 power, I get 81. So it checks out quite nicely. Okay, and it's always good to check it properly. So this does work. Okay, so if a and b are positive and a equals b, they equal each other, then log a equals log b. You can therefore solve an exponential equation by taking the logarithm of both sides of the equation. Okay? I can take a logarithm of both sides of the equation to solve it as well. So solving an exponential equation with different bases. Okay, so I'm going to solve 7 to the 3x equals 20. Okay? So I have 7 to the 3x equals 20. There's nothing I can get with 20 or 7, so I can get the same base. So I know that. So basically, if I take the logarithm of both sides, since 7 to the 3x has to equal 20, a equals b here, then if I took the log of 7 to the 3x, that has to equal the log of 20. I'm basically doing the same thing to both sides of the equation, so that doesn't change anything. So I'm going to simplify this. Okay, but using the properties of logarithms, I know that this 3x becomes 3x log 7 equals log 20. I want to isolate x all by itself, so I'm going to divide this by 3 log 7. So therefore, I will have x equals log 20 divided by 3 log 7. That would be the exact answer. If they asked for a decimal approximation, I'm just going to stick in log 20 divided by 3 log 7 into my calculator. And if I do that, I'm going to get approximately equal to, and make sure you put these in parentheses the right way, because if you don't put them in parentheses the right way in your calculator, you're going to get a really bizarre answer. Okay? In my Inspire, I can use a fraction, which makes it really, really nice. And I'm still going to use parentheses. On the top, I'm going to have log 20. Make sure you're not putting the 20 into the base. And I'm just going to skip the base 10 part, divided by 3 log 7. And of course, my T on Inspire is going to give it to me as log base 10 of 20 divided by 3 log 10 of 7. So I'm just going to tell it to change it to a decimal, so Control Enter. It's going to change that to a decimal, and I'm going to get approximately equal to 0.5132. So this is the exact answer right here. This is the approximated answer right here. And depending on what you're asked to give, we're going to give one or the other, or maybe even both. So let's practice a few more. And because the more you practice them, the better you get at them. All right, so now we have 5 to the 2x equals 16. Okay. So if I'm just going to do the same basic thing that I did before here, I have log 5 to the 2x equals log 16. So 2x log 5 equals log 16 by the properties of exponents. And if I divide by 2 log 5 here, I'm going to have x will equal log 16 divided by 2 log 5. And if I put that in my calculator, that will give me an approximation of approximately 2.8613. So as you can see, these aren't really hard. You just have to remember your properties of exponents, and you have to remember your basic algebra solving equations. Okay, so the answer here would be one or both of these, the exact answer, the approximate answer. Here's letter B. This one's a bit more complicated, but not really that much more complicated. I have 3x plus 4 equals 101, so I now have log 3 to the x plus 4 equals log 101. So I'm going to end up with x plus 4 log 3 equals log 101 by the properties of exponents. Okay, so I need to get x plus 4 all by itself first. So I'm going to divide by log 3. So the first thing I'm going to do here is I'm going to divide by log 3. So I'm going to have x plus 4 equals log 101 divided by log 3. And then to get x by itself, x is going to equal log 101 divided by log 3 minus 4. And if we put that in our calculator, x is going to be approximately equal to 0.20086. Okay, so again, you just have to remember how to solve equations. Because I couldn't subtract that 4 until I divided the log 3 out of it first. Okay, so I can't say, look at that and go, oh, because 4 was multiplied by log 3. So I had to divide it by log 3. Okay. Okay. Let's look at some more change of base formulas to solve an exponential equation, okay, which is basically what we were doing before. Okay, so solving more with change of base. If I have 2 to the 3x equals 172, okay, that means I have log 2 to the 3x equals log 172. So 3x log 2 equals log 172. If I divide by 3 log 2, I end up with x equals log 172 divided by 3 log 2. Okay. Which is approximately equal to, put that on my calculator, 2.47. So it's not hard to solve logarithmic equations. You can change it back and forth either way you want. The second way you can solve logarithmic equations is by graphing. Okay. Now, you have to remember a few things about logarithms. You have to understand your calculator a little bit to make this work really well. If I want to solve 6 to the 2x equals 1500, now I could set it equal to 0. so that I'd have 6 to the 2x minus 1500 equals y, and then try to find the intersection and calculate the 0. But I find that that doesn't work quite as well. It worked better in earlier chapters to set it equal to 0 and solve than it does in this particular instance. Here it actually works a lot better, including on the inspired, and have one equation y equals 6 to the 2x and the other equation y equals 1500, and find the point of intersection. But you will have to change your window on your calculator. So if I was to put this in my calculator, okay, I'm going to just get a new graph. Okay. So if I have y equals 6 to the 2x, 6 to the 2x power, and I hit enter, it's going to graph that nicely on my screen, and I'm going to see it pretty well. But if I graph y equals 1500 on my screen, I am not going to see that. If I want them on the same screen, which is what I want, if you're using the 84, you're just going to graph y1 and y2 on the same screen. If you're using the Inspire, after you graph y equals 6 to the 2x, just hit Control-G, and it's going to ask you for another equation, and you're just going to put 1500. And you're going to hit enter, and you might think, wow, that did not put that on my screen. It did, it's just not in your window. So now you need to get your window so that you can actually see these. So I'm going to do window zoom, and I'm going to do a window setting. Okay? My x minimum. Well, if I looked at my first graph, okay, I'm pretty much thinking y equals 1500 is going to be way up at the top of the y, and it's probably going to be in the positive of x. So my x minimum, I'm just going to put as -1. My x maximum I'm going to put as 10, and my x scale I'm going to put as 1. My y minimum, I know it's going to be way up there at 1500 where they have to cross. So I'm going to put my y minimum at like 400. I'm going to put my y maximum at 1600, and I'm going to go by 100s. Okay, so basically in my table I have an x min, and I put that as -1, and my x max I put as 10, and my x scale, I went by 1s. My y min, I put as 400. My y max, I put as a little bit higher than 1500, so I put it at 1600. And my y scale, I went by 100. And if I hit OK, then I'm going to see where my two graphs cross. I should have a graph that here's my x-axis and my y-axis. Can't even see my x-axis. I have a graph that goes like this, and then I have a graph that goes like that. This is the point of intersection. That's what I need to know what that point is. So now I'm just going to simply go menu. I'm going to do analyze graph, or if you're using the TI-84, you're going to go calculate, okay? And I want to calculate the intersection. Okay? So it's going to ask me to find my bounds, so I'm just going to go a little bit to the left and a little bit to the right of this graph, and you'll notice it gives me my intersection at 2.04. Okay, so if I get my intersection here, it's approximately 2.04. Now, obviously, if I do it this way, it's not going to give it to me in all those lovely little decimal points. Can I get all those little lovely little decimal points? Yes. Do I need them? Probably not. I could use a table if I wanted to as well. Okay, so that's the easiest way to do it, is to actually use the two different equations and make sure you adjust your window accordingly. Okay, some of your calculators may give you the value for x to be a bit more accurate at approximately equal to 2.408, but 2.0408 is 2.04. I'm pretty close. Okay, so what is the solution to these exponential equations? We're going to do these by graphing, not by using not by doing change of base. So I'm just going to plug into my calculator. I'm going to get into a new graph, and I'm going to graph one equation is going to be y equals 7 to the 4x. No, that was terrible. Y equals 7 to the 4x. And my other one is y equals 800. Okay, so we have those two equations. So if I graph those two equations, okay, if I graph y equals 7 to the 4x power as one graph, I get a nice graph on my screen, and then if I hit Control-G and add the second graph, which is going to just be 800, okay, again, I'm going to have to change my window. Okay, so on window zoom, I'm going to do window settings. I'm going to let my x minimum be -1, my x maximum be 10, and my scale be 1. I tend to keep that as a pretty good scale. My y minimum, I know they have to cross at 800, so let's make my y minimum 400. Let's let my y max be 900, and let's go by 100s. So then I can at least see where they're going to cross. And here they cross, and then I can do the menu, and I can analyze graph, calculate 0, or the intersection, excuse me, not 0, and I can calculate those. So if I go and pull that off my graph, I should get x is equal to 0.859. And you should be doing these on your calculator so that you can learn how to do them. Otherwise, you're going to end up with some really interesting trying to figure out how to do the answers while you're doing your homework. And if we do letter B, I'm going to let one equation equal y equals 5.223x, and the second equation is y equals 100. So if I do those, so if I have 5.223x as my first equation, I get a nice little graph. Okay. And yes, so there's the x-axis again. Okay. And then if I put Control G, so I can put in 400 here. Still won't come across until I change my window. So I'm going to change my window setting. Okay, and I'm going to have -1 as my x minimum, 10 as my x maximum, go by 1s. My y minimum, I'm going to make it be like, I'm going to make it 0 just for the fun of it. My y maximum, I'm going to make 500, and I'm going to go by 100s. Okay, so it will cross, and I can do the intersection. So I can analyze graph and do the intersection of those two graphs. And they intersect at 1.21. Okay, so if you understand how to use your calculator, you can find the decimal approximations to each exponential equation as well. Okay. So you can solve them algebraically, and you can solve them using your calculator by using a graph. All right, now let's model with an exponential equation. Wood is a sustainable, renewable, natural resource when you manage it properly. Your lumber company has 1,200,000 trees. You plan to harvest 5% of the trees each year. How many years will it take to harvest half of your trees? Okay. So, is an exponential model reasonable for this situation? Obviously it is, because if you're harvesting 5% a year, you have a constant percent that's changing. So it's a continuous, same exact percentage. So yes, an exponential is reasonable for this situation. So define your variables and determine your model. Okay. So remember, we're looking at remember the original form was a of n equals little a parentheses 1 plus r to the n power, okay, or t power, or whatever power you want to make it. Okay. So in this equation, I'm going to let little a be my initial amount, which is 1,200,000 trees. Okay, I need to know what r is. Okay, so r is the rate. Okay, and this is rate of decline, okay, which will be like rate of decay, which is 5%. So that's 0.05. I need to know, okay, and it's going to be negative because it's a decay. I need to know the number of time periods. Okay, n is going to be the number of time periods to harvest half the trees. Okay, number of years, because it's asking years to harvest half. Okay, so I think that's pretty much all I need. Okay. Oh, and I need to know what this is t of n, which is just like saying a of n, but now I'm doing trees. Is going to be half my trees. Half my trees is 600,000 trees, isn't it? That's half of 1,200,000. So now that gives me everything I need to write an exponential model. Okay, so 600,000, because that's t of n, is going to equal little a, which is 1,200,000, times 1 plus negative 0.05 to the n power. Okay, so let's simplify this a little bit. So I have 600,000 equals 1,200,000 times 1 minus 0.05 is going to be 0.95. Okay, 0.95 to the n power. I need to solve this for n. Okay, so if I take my equation, first thing I'm going to do is divide by 1,200,000. 600,000 divided by 1,200,000 is 0.5. So I have 0.5 equals 0.95 to the nth power. Okay. So if I take the logarithm of both sides, I can solve this because I don't have the same base here. So I'm going to do the logarithm of 0.5 is equal to the logarithm of 0.95 to the nth power. So now I can solve this for n. So I can take this and make this logarithm 0.5 equals n logarithm 0.95 by the properties of exponents and the properties of logarithms. So if I need to solve for n, I'm going to divide by the logarithm of 0.95 on both sides. So n will equal the logarithm of 0.5 divided by the logarithm of 0.95, and I will stick that on my calculator. Logarithm of 0.5. Turn the calculator on. So if I get a fraction here, logarithm of 0.5 divided by logarithm of 0.95 gives 13.53, 13.513, excuse me. I get n is approximately equal to 13.513. So the question asks, how many years will it take to harvest half my trees? It will take about 13.5 years. So if we don't constantly plant new trees, basically I'm going to have half as many trees as I did in 13 years, which means in another 13 years, I mean, if I have 5%, it's not going to take very long before I have no trees. It won't even last one generation in my family. So if I don't replant more trees, I'm not going to have very many trees left, which is why forests are constantly being replanted, because it takes a long time for a tree to grow. Okay, solving a logarithmic equation. Okay, there's 3 ways we can solve. What is the solution of log of 3 minus 2x equals negative 1? We can solve it using exponents, my favorite way. Okay, solve it using the graph. Not necessarily my favorite way, but it works. Or solve using a table, which once you have the graph, the table is really easy. So solving using exponents, I tend to like math, so I kind of like using exponents. So if I have log of 3 minus 2x equals negative 1. Okay. This is a logarithm here, and there's no logarithm here, but I know the log is log base 10. Okay. So if I multiply both sides by log base 10, I would get rid of the logarithm, so I'm going to end up with 3 minus 2x equals 10 to the negative first power, because if I multiply both sides by base 10, I get rid of the logarithm. Okay. Because remember, log base 10 of 10 equals 1. Okay, so if I multiply this by log base 10, okay, I can just get and make this into an exponent. Okay, so I'm using exponential model to solve this. So now I have 3 minus 2x equals 10 to the negative first. So 3 minus 2x equals 110, 4.1. Okay, so 3 minus 2x equals 0.1. So subtract 3. So negative 2x, we'll move this over here. Negative 2x equals negative 2.9. Divide by negative 2. X is going to equal 1.45. So that's solving it using exponents. Most of you probably don't like that method because it's more mathematical. It uses more work. If I'm going to solve using a graph, Okay, I'm just going to put two equations in. My first equation is going to be the log of 3 minus 2x. I'll put that as equation 1 in my calculator. The second equation is going to be negative 1. So if I put both of those into my graphing calculator, okay, so don't fit log, so I can log base 10, so I can do log of 3 minus 2x. I'll graph that. I get a nice little graph. And then I'm going to put in Control G to add my second equation, which is negative 1. And get that. So I basically have a graph that looks like this. Here's my x-axis, y and x-axis. I have a graph that is my logarithm that's coming down like this. And then I have the other graph, which is going to cross like this. And I need this intersection right here. Okay? That means that there's a lot more curves. So now I'm going to hit menu, and I'm going to do analyze graph, and I'm going to do intersection. Okay, so if I pull those, I can get the bounds of that. You'll notice it's 1.45. So x equals 1.45. Probably a little faster than using exponents. And obviously, once you have it in your calculator, you can hit Control T, go to your table, okay, and you want to know when y equals negative 1. Okay, so you're just going to scroll until you get y equaling negative 1. Okay, and you may have to change your table settings. Okay, because you'll notice if you don't change your table settings, at 1 you get 0, at 2 you get error. Okay, so I'm going to have to change my table settings, and I'm basically going to edit my table settings. So I'm going to have my, since I know it should be around 1.45, I'm going to have it start at 1.4, and I'm going to have the table set at 0.01. Okay, so then if I do that, if I do my table settings like that, you have to put leaving 0 in it doesn't like it. Don't know why. It just doesn't. And you'll find that that works at, it comes out to be 1.45. The table thing is the thing I don't like the most. Okay, so, because it's so annoying. So if you get this in if you get it 1.45, you'll notice it will be negative. Of all of them, I like either method 1 or method 2. I don't necessarily use method 3 because in order to get to method 3, you have to do method 2. So, you know, you don't have to do the intersection, but it's a lot easier. All right, let's solve some logarithmic equations. And we're going to solve these without the use of the calculator. We're not going to graph them. We're going to actually do them exponentially because that's the harder way, and I figure that's the way that's going to be a little bit harder for most of you. That does mean you can check them the other way, though. And it's always a good idea to check them the other way by graphing them. So if I have log of, okay, so now I've got log 3x plus 1. Okay, okay, so I've got 3x plus 1 equals 5. All right, so that gives me, okay, if I take the logarithm of both sides, or if I write this in exponential form, I'm going to have 3x plus 1 equals 10 to the 5th power, because we're taking base 10. This is base 10, so this will be 10 to the 5th power. So I just get rid of the logarithms by doing it that way. So I have 3x plus 1 equals, okay, 100,000. So if I subtract 1, 3x equals 99,999 divided by 3. So x is going to equal 33,333. Okay, kind of a weird answer, but it does work. And of course, I could check that by graphing. I wouldn't really want to, but I could. So it's going to be interesting. graph, but that's okay. All right, so let's solve a couple more. Log 7 minus 2x equals -1. So basically I have 7 minus 2x equals 10 to the negative first. So 7 minus 2x equals 1/10. Okay. Now, if I want to solve this, the easiest way to do that is multiply both sides by 10. So I'm going to have 70 minus 20x equals 1. So subtract 70. It gives me negative 20x equals negative 69. Divide by negative 20. X equals 69 twentieths. Which ends up equaling to. So they're not hard because of the fact that you have a logarithm and it's base 10, you're taking it what it's equal to 10 to that power. So if I get log 2x minus 2, that's log base 10 of 2x minus 2 equals 10 to the fourth power. So I have 2x minus 2 equals 10 to the fourth power. So 2x minus 2 equals 10,000. Add 2. 2x equals 10,002. Divide that by 2. X equals 5,001. I don't even touch my calculator for any of that. Now, in some cases, however, you must use the properties of logarithms to simplify the expression before you can solve the expression. These get a bit more complicated. If I wanted to solve 2 log x minus log 3 equals 2, right, the first thing I should do is I should try to write this as a single logarithm first. Since we're subtracting, we know we are actually dividing the logarithms. And since I have this on the outside, I know that that would be log x squared minus log 3 equals 2. So basically I have log x squared divided by 3 equals 2. Now that I've gotten to that point, now I can do the exponential part where I write it as an exponent. So I have x squared over 3 equals 10 to the second power. Okay, so I'm just going to do this over here so I have more space. So I have x squared over 3 equals 100. So x squared equals 300. So I'm just going to plot both sides by 3, or maybe do a proportion cross multiply. Okay, so x is going to equal the plus or minus the square root of 300. Okay, and x is going to equal 300 is 100 times 100 times 3. It's going to be 100 times 3, and the square root of 100 is 10, so it's going to be plus or minus 10 square roots over 3. So if we did that as a decimal approximation, it would be plus or minus 17.32. However, since a logarithm of a negative number is undefined, the only solution is going to be the positives of these. So x is actually equal to 10 square roots of 3 or 17.32, because you cannot take the logarithm of a negative number. If you put a logarithm of a negative number in your calculator, it won't come it's undefined. All right, let's do a couple more. So now we've got log 6 minus log 3x equals -2. So we need to write this as a single logarithm first. Since it is subtraction, that means we're dividing, so that would be log 6 divided by 3x. Okay. Which basically is the same thing as saying equals -2, not that part. That's the same as saying log of 2 over x equals -2. We can simplify that. So then that means 2 over x equals 10 to the negative second. Okay, so 2 over x equals 1 over 100. This is the proportion, so I'm going to cross multiply, so x is going to equal 200. Now, you didn't have to simplify first, it just made it easier, I think, in my opinion. I could have left it as 6 over 3x equals -2 and then done log it. We've done 6 over 3x equals 10 to the negative second. Still got 200. Okay, 3 log x minus 2 log equals 5. So we are going to have log of x, oops, box, no log log of x to the third over 2. Because we subtracted, that's division, and the 3 on the outside means that's x is taking that exponent. That's going to equal 4. So x to the third over 2 is going to be equal to 10 to the fifth. So x to the third over 2 equals 100,000. Okay, so x to the third equals 200,000. We want to do this cross multiply to solve for x to the third. So x will equal the cube root of 200,000. And if I put that on my calculator, the cube root of 200,000, let's see here. Cube root of 200,000 is about 58.48. So x is approximately 58.48. And this is exponential and logarithmic equations. The more you work with them, the better you get at them.